last video, we explained the design of the queue node in TDengine 3.0. This video will introduce the multi-table aggregation query in TDengine. The core design idea of TDengine is to create one table per data collection point. The time series data collected from each data collection point, DCP, is stored in separate tables. But in practical applications, it's often necessary to aggregate the data from different DCPs. In order to perform aggregation operations efficiently, TDengine introduces the concept of the supertable. A supertable is used to represent a specific type of data collection point. It is a table set containing multiple tables with the same schema, but each having its own static tags. A supertable can have multiple tags, and you can add, delete, and modify the tags at any time. Applications can perform aggregate and statistical operations on all or a subset of the tables under a supertable by specifying tag filters. This makes it much easier to develop applications that use your time series data. Aggregation involves clients, M nodes, V nodes, and Q nodes. Now let's go over the process for aggregating data across multiple tables. First, the client requests the metadata for the database and tables from the M node. The M node returns the requested metadata. The client sends query requests to every V node in the supertable. Each V node performs the query locally and returns the results to the client. The client sends a query request to the Q node, which is responsible for aggregation. The Q node requests the query result data from the V nodes involved in the query. Each V node returns its local query result data to the Q node. The Q node aggregates the results from each V node and returns the aggregate results to the client. At this point, the client has obtained the results of the aggregation query that it performed. Since TDengine stores tag data and time series data separately on V nodes, filtering tag data in memory and finding the set of tables that are part of an aggregation operation increases aggregation speed by reducing the volume of data to be scanned. At the same time, because the data is distributed among multiple V nodes or D nodes, the aggregation operation can be carried out concurrently on multiple V nodes, which speeds up the process further. This is how aggregation queries are executed in TDengine. If you'd like to know more about TDengine, you're welcome to download the source code from our GitHub repo and visit our official website at tdengine.com.